Hello dear learner, I Dr. Tarkeshwari Verma welcome you in this Macy Open online course of Fundamental of Engineering Physics. In a previous lecture, we studied about the light ray, reflection, refraction and different phenomena related to the light. In today's lecture, we study about very interesting topic. Okay, let's tell me one thing. You heard about the X-ray? Where you heard? In general, medical cases, in a hospital, in diagnosis system, everywhere we use the X-ray word. So, do you know what is the X-ray, how it produce, how its work, and what's the application? Today we will discuss about the X-ray. So today's lecture objectives are introduction of the X-ray, history, what is the electromagnetic wave, type of X-ray, production of X-ray, different type of component using to production of X-ray and different types of application. X-ray are remarkable from the electromagnetic radiation, a superpowered version of the ordinary light. Unlike visible light, X-ray have much shorter wavelength and higher frequency. When X-ray encounter substance, they interact with its atom. Electrons which around these atoms play crucial role. Some material allow X-ray to pass enough effectively while others halt them in their tracks. Imagine firing X-ray at the crystal. The atom scatters the beam, creating shadow that reveal the crystal internal pattern. They help us peer inside body, study material, unlock hidden material. So while we see through our skin like X-ray do, we can certainly appreciate their incredible impact. Before starting the X-ray topic, we should know some fundamental key aspects like electromagnetic waves. Electromagnetic wave consists of synchronized oscillation of electric and magnetic field. This field oscillate perpendicular to each other and propagate through the space. Each one has two components. Electric field oscillate with the one direction. Magnetic field oscillate with the same frequency but with the 90-degree phase shift relative to the electric field. They have some properties like transverse wave. Electromagnetic waves are transverse, meaning their vibration occurs perpendicular to the direction of wave travel. In the vacuum, like other space, electromagnetic waves travel at a speed of light. Electromagnetic waves form a continuous spectrum with the varying wavelength and frequency. That is the group of spectrum. These waves can categorize into 7 distinct groups, including visible, which our eyes detect, and other ranges like X-ray and radio waves. They are hazard also. Some electromagnetic waves can be hazardous to human tissues like X-ray and other radiation like gamma, beta. UV radiation from the sun can causes for skin damage. Let's explore all the types of electromagnetic waves. First is the radio waves. Lowest frequency waves in an electromagnetic spectrum. Frequency range varies for the kilohertz to gigahertz, thousand of the kilometer or the more, that are generally used in a communication like radio and TV, emitted by natural object and man-made sources. Second is the microwaves, slightly higher frequency than radio waves. Their frequency range belongs to gigahertz to terahertz, ranges from the millimeters to centimeters. under the radar, lead 9 force and data transmission and cooking. Penetrate observed like cloud and smokes also. Infrared waves. Between the microwaves and visible light, the frequency exists. That frequency range is the terahertz to the petahertz wavelength, micrometer to millimeters. Produces heat, used in a remote control and imaging technology. Next our reason is the visible light rays. That is the light range where human eye detect that colors, enable to see the world. Different color based on the wavelength comes on the visible light range. The frequency range the picohertz to exahertz, approximately 400 to 750 nanometer. Sunlight is the natural source of the visible light. Ultraviolet waves, shorter wavelength than visible light, causes sunburn and can be harmful in our skin also. The frequency range is the eta hertz to zetahertz. Ranges from the nanometer to hundreds of picometer. They detect from the stars and the skies. Next reason is the X-ray, that is the high energy waves used in a medical imaging. The frequency range is the zetahertz to yottahertz. Wavelength much smaller than atomic nucleus. Absorbed by the dense structure like bones. Gamma rays, highest energy waves, frequency range beyond the eta hertz wavelength, extremely shorter wavelength that belongs to subatomic scales, emit during the nuclear process. Let's explore the fascinating world of X-ray and understand the difference between the hard X-ray and soft X-ray. Hard X-ray in with a high photon energy above 5 to 10 kilowatt fall into the category in a hard. They have some characteristic like short wavelength and high frequency. Penetrating ability is the can pass through the dense material. They use in a medical radiography such as a bone imaging and determining the crystal structure via X-ray crystallography. Short ray X-ray, widely used in a medical radiography and determining the crystal structure via X-ray crystallograph. Soft X-rays. Soft X-rays have lower energy compared to hard X-ray. They have longer wavelength. They have some characteristics also. Longer wavelength around 10 nanometers to more, easily observed in air and other material. They used in a specific scientific studies and imaging. Their high penetration is not necessary. Let's explore the spectrum. Electromagnetic radiation spans a continuous spectrum with different type of the characteristics, their wavelength and frequencies. Radiation is the emission or transmission of the energy in the form of the wave in a particle through the space or a medium. It occurs naturally and it can also be generated artificially. Radiation is the broadly categorized into the two types, ionized and non-ionizing. Ionizing radiation such as the X-rays and gamma rays carries enough energy to ionize atom, potentially causing damage to living tissue. Non-ionizing radiation including radio waves, microwave and visible light does not have sufficient energy to ionize atom but can still have significant effects such as heating. Radiation is the widely used in a various fields including medicine, communication and energy production, but it also requires careful management due to potential health risk. Let's explore the ionizing radiation in a detail. refer to the radiation that carries enough energy to ionize atoms or molecule by removing tightly bonded electron. This process can cause significant chemical changes in a material, including biological tissue, potentially leading to the cell damage. They have some example include X-ray, gamma ray and high energy particles such as the alpha and beta particles. Ionizing radiation commonly used in a medical imaging, cancer treatment and nuclear energy. Non-ionizing radiation, that radiation does not have sufficient energy to ionize atom or molecules. It can excite atoms but cannot remove electron. Non-ionizing radiation is generally considered less harmful than ionizing radiation. Enough, it can still causes the damage of high exposure level such as a heating tissue. That have some example in a visible light like microwaves, radio wave, ultrawaves light and infrared radiation. Non-ionizing radiation is widely used in a communication, in a field of radio or TV or cooking also. Ionizing radiation is also classified into two categories based on their interact with the matter. Directly ionizing radiation and second one is the indirectly ionizing radiation. Directly ionizing radiation consists of charged particles which have ability to ionize atom or molecule directly enough to interaction as they pass through the matter. The energy this charged particle is transferred directly to electron to material causing to ionization. Types of directly ionizing radiation. Alpha particle, highly charged particle emitted by certain radioactive material. They have ionizing power but low penetration. Beta particles, high speed electrons or positron with the moderate ionizing power and penetration capacity. Protons, positively charged particle found in the nucleus of atom which high ionizing ability and significant penetration. Indirectly ionization radiation, that consists of the uncharged particle or electromagnetic radiation. This do not ionize atom or molecule directly but can produce charged particles when interacting with the matter, which they go on the cause of ionization. Types of indirectly ionized radiation. Gamma rays, high energy electromagnetic radiation that can penetrate deeply into the material. They causes ionization indirectly by interacting with the atomic electron or nuclei. Produce secondary electrons. X-ray, similar to the gamma ray but typically produced by electronic transition in an atom rather than nuclear transition. Neutrons, uncharged particles that can causes of ionization indirectly through the nuclear interaction, producing secondary charged particle that can be ionized atom. Let's understand some properties of X-ray. There are the many types of properties like the wavelength of the electromagnetic spectrum of X-ray are short. X-ray require high voltage to produce. X-ray are used to detect defect of human skeleton. X-ray waves always travel in a straight line and they do not carry any energetic charge with them. And also the X-ray is capable to traveling in a vacuum. X-ray cannot be easily refracted. X-ray waves do not get affected by the electromagnetic fields. X-ray causes a photoelectric emission. X-ray having short wavelength and a high penetrating ability and very destructive. This is the reason why they known as the hard X-ray. The use of X-ray in the medical field have less penetrating power or a longer wavelength, and hence they call the soft X-rays. We already discussed about the hard X-ray and soft X-ray. Let's know about the discovery of the X-ray. X-ray were discovered on November 8 Novembers on year of 1895 in a William Carnot, who is the German physicist that stumbled upon this groundbreaking discovery while experimenting with cathode rays. Röntgen is noticed that fluorescent screen in his lab began to glow when exposed to an unknown type of radiation emitted from nearby cathode ray tube, even when the tube was covered. He called the new form of radiation X-ray. That time X-ray representing unknown thing. That discovery was intermediately recognized as a notable achievement in a science and medicine. He conducted that discovery is the discovery of this called the new is the radiation is the X-ray, where the X-ray representing the unknown thing. That discovery is the very useful for the science and medicine field. He conducted further experiments. He conducted further experiment, famously taking the first X-ray image of his wife's hand, which clearly shows her bones and wedding rings. This image is demonstrated the potential of X-ray to visualize the internal structure of the human body without invasive surgery. The discovery of X-ray revolutionized medical diagnosis, allowing the doctor to see inside the patient body. Within a year, X-ray were being used in a clinical setting for the diagnosing fractures, locating other objects and other medical applications. The development of X-ray technology continued throughout the 20th century, leading to the advanced imaging technologies used today, such as the computed technology, CT scans and digital radiography. That discovery earned his first ever Nobel Prize on the physics in 1901. Let's explore each and every component of the X-ray tubes. An X-ray tube is the complex device composed of several key components that work together to generate X-ray. Here the detailed explanation of each and every component. First is the cathode, that is also known as the filament. The cathode consists of a thin tungsten filament which is heated by the electric current to produce electrons through the thermionic emission. Tungsten is used due to its high melting point and efficient electron emission properties. A focusing the cup typically made of the nickel surrounds the filament. Its shape is the direct that emits electron into focused beam, ensuring that they travel toward the specific area of the anode. The effectiveness of the focusing cup is the crucial for producing the sharp X-ray beam, which is the impact image resolution. Next part is the anode, that is also known as the target. The anode is the crucial part of the X-ray tube where the high speed electrons from the cathode collide to the produce X-ray. It is the usually made to the tungsten because the high atomic number with the increase the efficiency of the X-ray production, and it is the high melting point with the point which is the responsible of the heat generation. The anode can be either stationary or rotating. It is the rotating anode and the target disk rotates rapidly, distributing the heat over the larger surface area, thus allowing the higher tube current and the shorter exposure time without damaging the anode. The anode angle is typically between 7 to 17 degree, affect the focal spot size in the distribution of the X-ray beam, influencing image sharpness and the contrast. Next, our component is the vacuum enclosure. The cathode and anode are housed within the vacuum sealed glass or a metal enclosure. The vacuum is the insertional as it prevents the electrons from the interacting with air molecules, which would be scattered and reduces the efficiency of X-ray production. This vacuum also protected from the filament from ionize and ensure the long tube life. Next is the power supply. The power supply providing the high voltage necessary to accelerate the electrons from the cathode to the anode. The voltage determines the energy of the X-ray produced, with a higher voltage producing more penetrating X-rays. The power supply also controls the tube current, which determines the number of the electron hitting the anode and the intensity of the X-ray produces. Next is the cooling system. Given that 99% of the energy from the electron collision with the convert into the heat rather than X-ray, effective cooling is the insertional. Only 1% is the participated in the production of the X-rays. So, cooling is the necessary thing to cover the generated heat. In a rotating anode, is the rotation itself help to dissipate the heat. Additionally, oil baths, fans or water cooling system are often employed to prevent that overheating and maintain optimal operating temperature. Filler and collimators. Often the made the aluminum is the place the path and X-ray beam to remove low energy X-ray and would be contributed to the potential without the improving the image quality. The collimator is an adjustable device that narrow the X-ray beam to the described size and shape, determining the patient exposure and preventing image constraint. Each of these components play the crucial role in ensuring the X-ray tube function efficiently, producing high quality images while they minimize the picture quality which we want. Functionality, how it functions, how it produces X-ray. When the electron heat to the anode, about 1% of energy converted to X-ray, while the remaining 99% energy converted to the heat. The anode is often rotated to dissipate the heat to prevent damage to the tube. Beam filtration. A filter typically made is the aluminum and used to remove lower energy X-ray from the beam, which are the less useful for the imaging and contribute to the unnecessary exposure. Collimation. The X-ray beam is usually collimated or focused to direct the X-ray toward the area of the interest and reduce exposure to surrounding tissues. Brembasting, that is the word. It is the German word. Actually, that means the barking radiation. The type of electromagnetic radiation produces when charged particle, typically electron, is accelerated or deaccelerated. Here the detailed explanation of this Brembasting process. This process occurs when the high energy charged particles such as the electron is deflected by the electric field of the atomic nucleus. The deflection causes charged particle to lose energy in the form of the radiation. The energy lost by the particle is emitted as the proton, which is known as Brembasting radiation. Behind the mechanism is When an electron passes near the atomic nucleus, there the nucleus exerts a force on the electron due to its positive charge. The force causes the electron to accelerate or deaccelerate. Energy loss. According to electromagnetic theory, any acceleration or deacceleration of the charged particle result of the emission of the electromagnetic radiation. Thus, the electron loses some its kinetic energy as it interacts with the nucleus. The lost kinetic energy is emitted as a photon, which is the called Bremsstrahl's radiations. The energy of the photon composes the amount of the energy lost by the electron. Continuous spectrum. Unlike characteristics, X-ray with have discrete energy level corresponding to the scientific electronic transistor that has the continuous spectrum. This is because of emitting the photon energy can vary continuously depending on the amount of the kinetic energy lost by electron. Intensity energy dependence. The intensity of the Bremsstrahl radiation increases with the atomic number of the material and the energy of the incident electrons. Higher atomic number result in a stronger electric field from the nucleus, which enhance that process or radiation or emission also. X-rays produces when a high energy electron knock the inner cell electrons out of the atom is targeted material. This create vacancies of inner electron cell. Electrons from higher energy level to fall into these vacancies, releasing energy in a form of X-ray. X-ray produce discrete sharp peak in X-ray spectrum. These peaks correspond to the energy differences between the specific electron cell in targeted material. Each element has unique set of characteristics X-ray line, such as the K alpha, K beta lines, where the K alpha line result from the transition to K shell from the L shell, and K alpha, and K beta lines result from the transition of the K shell from the M shell. Energy level. The energy characteristics X-ray specific to the target material and electron cell transition involved. For example, tungstens commonly used to X-ray tube has X-ray that have peaks and energy like 59.3 kilowatt for K alpha and 67.5 kilowatt for K beta. In a X-ray spectrum graph, we can see that the spectrum is to typically represent the intensity of X-ray radiation against the photon energy. Sharp peak appear the specific energy correspond to the characteristic X-ray corresponding to the X-ray emission. These peaks are usually seen as distinct line in a spectrum. The curve starts from very low energy and extends to the high energy with the intensity decreases with the higher energy. In upcoming lecture, we studied about the laser and laser fundamental concept, production and application parts. Hope so you enjoy this lecture and you understand very well. Thank you for your being patience.